Hello everyone, this is just a brief intro video for Lab 3. So, as promised for Lab 3, we have in our wind tunnel a vertical airfoil. If we look at the top section, we can see that this is indeed an airfoil with the top surface of the airfoil towards the near side of the wind tunnel and the far side of, or the bottom of the airfoil, facing the wall with that large outlet over there. And then behind the airfoil, we have our 18 pressure ports that are measuring specifically total pressure for our case. So this airfoil is mounted onto the turntable. We can adjust this with the black lever underneath. It's most handy to adjust it instead of just pushing on this because it'll tend to move in quite large increments. It's generally better to adjust this by tapping it. So if we want to go to 5 degrees, we can do that much more precisely just by tapping this several times rather than trying to yank it to 5 degrees. One thing to note, this says 5 degrees right now. All right, it's halfway between 0 and 10 on the major mark. This airfoil is very clearly pointed slightly down. This is actually a negative angle of attack. The angle of attack of this airfoil is the negative of whatever angle this turntable shows. So this says positive 5. That means this airfoil is at negative 5 degrees angle of attack. For this test, we will be going from negative 2 degrees there we go. Negative 2 degrees on the airfoil, so the angle of attack is negative 2 degrees. But on the turntable, it says positive 2 degrees because it's the opposite of what we want in terms of sign. And then we will be moving this up through positive 8 degrees angle of attack, or negative 8 on the turntable in 1 degree increments, so 1 degree at a time. So we have our 18 pressure ports connected to these 18 pressure tubes. Those are ports 1 through 18. One piece of information you do need that you don't have yet is you will need to know what the width of this pressure rake is so you can know the physical distance separating them. I will give that to you at a later date. That's not immediately necessary, but you'll notice we also have the pitot tube installed in the wind tunnel. This is port, I believe, and a couple of you I may have stated this incorrectly. I'll have to clarify with an announcement just to make sure you all get it. If we look at the total pressure port here, we can see that this is connected to the last port available. So total pressure is on port 20. Static pressure is on port 19. I'll have to make a clarifying announcement about that. Because this has not changed since I started doing this lab experiment for everyone. So static pressure is port 19, total pressure is port 20, and ports 1 through 18 are the total pressure ports behind our airfoil. So give me just a second here. There we go. Only took about 3 tries to type that in correctly. So I want to show you a little bit about what we'll see when we run this. Let the software come up first, and then we'll go ahead and get started. This lab is pretty quick. Like I said, we're only doing 11 measurements. So we will want to note the angle here. So if this was negative 2 degrees, or positive 2 degrees on the turntable, which is negative 2 degrees angle of attack, we put in negative 2 over here. So P1 through 18 are what we call the pressure rake, which is the rake looking thing behind the airfoil. P19 is pitot static, and pressure 20 is the pitot tube total pressure. And clearly we're taking pressures, not forces, so we need to use the PTA tab, pressure transducer array. We go ahead and initialize that, and we're going to look at a pretty small range. So we can look from about 1016 down to 1000, and that's probably a little bit large as is. So we'll go 1005 to 1016. These numbers might change a little bit depending on how much our pressures change, but this should let us see how pressures change here once we get this started. As usual, we're using a sample mode, except we're using 100 samples per. So let me just go ahead and go through the first couple of these. We'll set this to 2 degrees, or negative 2 degrees, which is 2 degrees on the turntable. And we're going to bring this up to 70% power. Notice that some of the pressures are lower here, and our static pressure is much lower. Notice this changed a little bit. And then for the sake of argument, I'm just going to change it very quickly through all the remaining angles without taking data. So I don't know how well you could hear me over that. Hopefully you could hear me a little bit. But again, the important part is every time you change the angle, you update this number, use this enter, not the other one. If you use the other one, you will regret it. Wait for the angle to be changed over here and tell it to take data, and wait until it's done taking data before taking the next angle. Rinse and repeat. You might have noticed the pressures and how much they changed and which ones changed as we change the angle of attack. That's going to change our momentum out. So again, this entire thing is about looking at momentum in, approaching the airfoil, and momentum out, behind the airfoil. If we know the difference, we can calculate how much force in the X direction is acting on the air around this airfoil. If we know how much force is acting on the air, we know how much force the air is putting on the airfoil, and we can calculate the drag, which is the objective of this lab. One thing to note, we do need to use speed lock because we are changing the geometry inside the wind tunnel. If we do not use speed lock, our velocity will change. That's pretty much it. I think this is a pretty quick one. Note, you'll have about 1,100, or you will have pretty much exactly 1,100 data points by the time you're done with this, not 200. But I will caution you, the data processing for this one involves numerical integration. over 18 different points. So you should probably set aside more time for the data processing for this one because it's going to be somewhat more intense. Calculating the velocities from our 18 pressures is relatively straightforward, but numerically integrating those velocities to get momentum is going to be a little bit more difficult. Other than that, I think that pretty much covers everything. So I'm going to leave this here and post this up for you guys to watch, and we will talk further about this a little bit over the next couple of weeks.